Here is another keyword for our formulas. Now in this case we have an angle for the force and also the angle for the plane. So in other words, we will have two sets of components. We have to resolve first the weight into components and thereafter resolve our Ft into components. Then make sure that your F mu again will oppose the component that is parallel to the incline. So that's what we should do for this particular case. Now a question might say find the magnitude of the force that is pushing the block up, which is Ft, or it might even say find the magnitude of the weight of the block or the mass of the block. So now we need to make Ft the subject of the formula, W the subject of the formula, or M the subject of the formula. How can we do that? Let's see. We are using equilibrium equations, as you can see, for first the parallel forces and then for the perpendicular forces. I'm sure you're noticing that Ft is on both of these formulas. Same goes for W, and remember W is equal to mg. So that means even for M it will be the same thing. Therefore we need to go and find the formula for mu and manipulate from there to other formulas. Starting with Ft, this is the answer for Ft, and then W and also M. But there is a video that I showed you how do I go about getting all of those, like doing all the manipulation thing. If you haven't seen that video, just scroll down to the description below and look for that link. I have it inserted on the description below this video as you are watching it. Without wasting any time, let's move on to the next part under this topic. Pulling down the slope, that's what you should look for in order for you to use the formulas we'll get from this description. Otherwise everything is just like the previous section. We have two sets of components, both for weight and also for Ft. But we want to make Ft the subject of the formula. So how can we go about it? We follow the same concept as we did on the previous one. We have the sum, we have equated our parallel forces to the plane and also our perpendicular forces. We can see that Ft appears on both formulas just like W. From there we can again find first Ft, then W, and remember W is equal to mg. Then after that we can find M, and M and W, those formulas are very closely related together because M is a product of W. So that's how we do it. There's no chill in Mzansi, guys. So without wasting any time, let's move to the pushing down. Again, we will follow the same concept. We can see that we are pushing it down with our Ft being at an angle from our inclined plane. So in other words, we need two sets of components for W and for Ft. Then F mu is opposing our parallel component of our Ft. Then we need to make Ft the subject of the formula, and we have to follow our usual routine, which says we equate the parallel forces and then we equate the perpendicular forces. Since we can see that Ft as well as W appears both on F mu and NR, therefore we need to go and substitute from the formula of mu, which says mu is equal to F mu over Fr. Substitute for F mu and NR. Then after that we can go to find our Ft, make Ft the subject of the formula, then make W and then M the subject of the formula, and it's easy for M because you just divide by G where we had W. Guys, if you're not pausing, you might not understand everything that I'm saying, because some of the times I say things fast. If you're not pausing and you're not understanding, you may as well go and sleep. Just make sure you understand, pause in between the sessions, pause, make sure you take down the notes, you analyze it well, you do your own analysis, you make sure that you're understanding what I am saying. Then, without wasting any time, let's move on to the pulling up part. At this point, I'll be like I'm running the marathon because we've been repeating the same concepts over and over again. So now I will just browse through them and quickly finish. Number one, we have two sets of components. Then we have the ones that are for a weight, we have the ones that are for the force that is being applied, that is pulling up our body. Number two, we need to equate our parallel components and also equate our perpendicular components, ensuring that F mu is in the opposite direction from the parallel component of Ft. Number three, we need to notice that Ft appears on both of our equations, both for the equations of Nr and F mu. Therefore, we should use the formula for mu to find Ft, and then make Ft the subject of the formula as well as W and M. That's it. See you guys when we are doing our examples. Cheers.